I am the student of BS Physics. And my topic is blackbody radiation. Blackbody radiation, first of all, what is the definition of blackbody radiation? Blackbody radiation is the thermal electromagnetic radiation within or surrounding a body in thermodynamic equilibrium with its environment emitted by a black body, then absorption of black body. A black body or black body is an idealized physical body that absorbs all incident electromagnetic radiation, regardless of frequency or angle of incidence. It does not only absorb radiation but also emit radiation. The name black body is given because it absorbs radiation in all frequencies, not because it only absorbs. Then a white body. A white body is one with a rough surface that reflects all incident rays completely and uniformly in all directions. Black body in thermal equilibrium. A black body in thermal equilibrium emits electromagnetic radiation called black body radiation. The radiation is emitted according to Planck's law, meaning that it has a spectrum that is determined by temperature alone, not by the body shape or composition. Then the properties of ideal black body came. The properties of an ideal black body in thermal equilibrium are given below. There are two properties of black body. It is an ideal emitter. At every frequency, it emits as much or more thermal radioactive energy as any other body at the same temperature. It is also a diffuse emitter. The explanation of diffuse emitter is measured per unit area perpendicular to the direction. The energy is radiated isotropically independent of radiation. An approximate realization of a black surface is a hole in the wall of a large insulated enclosure, an oven for example. Black body and thermal equilibrium. To stay in thermal equilibrium, black body must emit radiation at the same rate as it absorbs, so a black body also radiates well. Uh, Radiation from a hot object. Radiation from a hot object is familiar to us. Objects around room temperature radiate mainly in the infrared. A good example of black body is given below. A good example of black body is a cavity with a small hole in it. Any light incident upon the hole goes into the cavity and is essentially reflected out, since it would have to undergo a large number of reflections of walls of the cavity. Then there are many advantages and disadvantages of black body. Then the applications of black body are given below. Black
यार
body
इसको
radiation is used for testing.
कैमरा आपका साइड पे जा रहा है, हमें कुछ नहीं पता चल रहा, या उसके ऊपर डालो या फिर जुबानी दे दो, क्योंकि आप हाँ उसके ऊपर फोकस करो कैमरे को, आपको भी नजर आता है कैमरा।
ठीक, सर अब नजर आ रहा है?
हाँ जी, आपको पता नहीं चल रहा होता आप जो दिखा रहे हो क्या दिखा रहे हो? मतलब मैं
सर
हर
वो
हर
साइड पे
हर
हो गया।
हर बच्चे को कहता हूँ कि भाई आपको नहीं पता कैमरे में क्या आ रहा है, ना तो वो खुद ही अंदाजा कर लेते हैं। बाकी क्या मतलब ना आवाज सही आती है ना तस्वीर आती है, तो या फिर जुबानी दे दिया करें या फिर सही फोकस किया करें। अगर सही फोकस नहीं होता तो जुबानी बता दिया करें।
Applications of black body. Black body is used for testing, heating, lighting, uh, measurement measurement applications. A black body source with a known temperature is used for calibrating and testing the thermometer. Then there are also the disadvantages of black body, which are given below. The main disadvantage of black body radiation is that the emission rate is the same as the absorption rate. This means black body substances cannot retain any energy for themselves except when heated for long periods of time. Ideal black body. An ideal black body is the body which emits radiation in all frequency ranges, emitting more energy as the frequency increases. It is also very difficult to attain a ideal black body. uh, Light entering process in the black body. A light entering the hole is reflected or absorbed at the internal surfaces of the body and is likely to re-emerge, making the hole a nearly perfect absorber. Real materials emit energy at a fraction called emissivity of blackbody energy levels. By definition, a black body in thermal equilibrium has emissivity of phi is equal to 1. Then the diagram of black body comes. Black body diagram, here is the diagram of black body in which there is blue star, yellow star, red star, and there is flux on the x-axis and wavelength on the y-axis. It is also the graph of black body radiation. Then the explanation of graph is given below. The graph of the amount of the energy inside the oven per unit volume, per unit frequency interval plotted versus frequency is called black body curve. The different curves are obtained by varying the temperature. If we change the temperature, then the curves are also changed, and the picture of the graph can also be changed of the black body radiation. Uh, uh, then the astronomy topic comes in the black body. In astronomy, the radiation from stars and planets is sometimes categorized in terms of an effective temperature. The temperature of a black body that would emit the same total flux of electromagnetic radiation. Then the process comes in the then the process of light entering comes uh, uh, in the topic of black body. Any light entering the hole is reflected or absorbed at the internal surfaces of the body. Uh, Real materials emit energy at a fraction called emissivity of black hole energy levels. By definition, a black body in thermal equilibrium has emissivity of phi is equal to 1. Uh, any light entering the hole is reflected or absorbed at the internal surfaces of the body and is likely to re-emerge, making the hole a nearly perfect absorber. When the radiation confined in such an enclosure is in thermal equilibrium, radiation emitted from the hole will be as great as from any body that equilibrium temperature. Radiation from a hot object. Radiation from a hot object is familiar to us. Objects around the room temperature radiate mainly in the infrared. सर हो गई
चले ठीक है।